This lesson is about evaluating functions and being able to use function notation. So we're going to start off by talking about function notation and what function notation is, what it represents, and how we use it. So this piece right here, this letter F tells me my function name. So this is function F. This tells me what variable I'm using as my input. So our input is X. And then this piece right here tells us what our actual function is doing. So our input is X. Our output is the entire statement F of X. And I would say that F of X. And this is just like saying Y equals. It's the same basic principle. So that's function notation, and we're going to learn in this video how to use function notation when we are doing evaluating functions. So we're going to look at three different functions. We're looking at function f, function g, and function j. And we're going to learn how to evaluate those functions based on the name and how we are given a representation. So I'm going to use pink for input and blue for output. So here, if it is inside of the parentheses like this, I'm going to scroll back up just a little bit. This is an input value. So if the number is inside of the parentheses, they've given us the input. So this tells us that if I'm looking at function f, my input is x equals 2. So I'm going to go back to function f, and I'm going to take x equals 2. So I have 3x plus 1. I'm going to replace x with 2. So that will say 3 times 2 plus 1. So our final answer is going to be an output value. So our function f of x, when our x value is 2, gives us 7. And this is our output value. So now I'm going to do the same thing, but I'm doing this with function g. So I know that my x value is now -2. My function g is 8 divided by x. So I'm going to take out x and replace it with -2. So I'll have 8 divided by -2, and that answer is going to be our output. That will be -4. So we know our output value for function g when our input value is -2 turns out to be -4. And now we're going to do function j when x is equal to 3. So my function j says that I'm doing 5 minus x. So I'm going to take 3 and replace x with 3. So that means I'm going to be doing 5 minus 3, which gives us our output value of 2. Now, f and h are different because now they're saying our whole output value for function f turned out to be 10, and our goal is to find our x value. So I'm replacing in this original function I'm replacing this whole output f of x with 10. So now it's going to say 10 is equal to 3x plus 1. So now in my head I'm thinking, what x value will give me 10 when I substitute in? For right now, we're okay just doing guess and check. So if I substitute in 2 before, when I did x equals 2, 3 times 2 gave me 6, plus 1 more gave me 7, so that's not enough. So let's try 3. 3 times 3 would give me 9, plus 1 more would give me 10. So I know here my input value of x would have to be 3. Same thing over here for function j. I know my output is 4. So I'm going to take j of x and I'm going to replace that whole thing with 4. So 4 is equal to 5 minus x. So what x value, when I subtract it from 5, leaves me with 4, and that would be x equals 1. So now we're going to go ahead and look at some graphs. So here's our first graph. So I'm going to do the same thing. I'm going to label input with pink, and that's the number that's inside of the parentheses. So since all of these are inside of the parentheses, those are all input values. So I'm going to go to x equals -1. I'm going to go to x equals 2. And I'm going to go to x equals 0. And my goal is to figure out what my output value is when x is -1. Oops, forgot my negative sign here. All right, so let's go to where x is -1. So here is -1 for x. And I need to go to where on my function my point would be. So now looking at that function, my goal is to find the output value for this point right here, which would be 1, 2, 3, 4, 5, 6, 7. So here, my answer would be 7. I'm going to do the same thing when x is equal to 2. Well, 1, 2, here's x equals 2. I'm going to go down. There is my point on this black line F, where x is 2, and the output value for that is right here. So this would be -2. Then I'm going to go to where x is 0 and find my point on my function where x is 0. And that's at a y value of 2. Part D is different because I've told you the output value is 8. So now I need to go up to 8. 1, 2, 3, 4, 5, 6, 7. Here's where the output value is 8. I'm going to go over to this point here. And I'm going to estimate here since we're off just a teeny tiny bit, and I'm going to use this next tick mark as my estimation. So here's my x value, 1, 2, x equals 3. I just realized there's one other question that got pushed off of the page. So I need to figure out for part E what happens when my output value is 2. Now with this one, I'm actually going to draw y equals 2 onto my graph because you'll notice if I follow along my function, I hit not once, not twice, but 3 times altogether on this line y equals 2. This point, and that point. So my goal is to find all 3 of those x values. So here would be -2.5. So I would have x equals -2.5. Here we have x equals 0. And then lastly, right here we have x equals +2.5. And the reason this one has 3 answers is, again, because I've hit my function 3 different times on that horizontal value of y equals 2. So we have another graph to look at just as extra practice. So the first thing we're going to do is just practice with domain and range again. So domain is the space we cover horizontally. So I start with my starting point, which is at -5. These are all x values. I'm going to go to my far right point, which is at x equals 4. And since those are not arrows and they're actual coordinates, I don't have infinities, and these will have equal to's. And then we're going to do the same thing for range, but I'm going to use my absolute maximum and my absolute minimum. And I go from the smallest number to the biggest number. So I have -4 is less than y is less than 3. And again, these are both going to get equal to's because there is not arrows and there are actual points at both of those y values. Now going back to evaluating, I have -5 and 2 as x values that we need to look at. So here I have x equals -5 and I have x equals 2. So at -5, I'm at this point right here. For an output value, that brings me to 1. When I'm at x equals 2, I'm right here. I need to, in this case, travel down to get to the point of our function right here, where my y value is -4, and we already had that point circled because that was our absolute minimum. And then for part E, I'm doing everything I just did backwards because I've been given an output value. So this is like saying y equals -2. So I'm going to go down to -2. Here's where my y value is -2. So I'm going to draw a horizontal line. And I'm doing that in this case because we again have a scenario where I have 2 points I need to consider. So for this one, I have x equals 1, and I have x equals 2.5. And both of those are answers. All right, last but not least, we're going to look at what happens in a table. There was a typo, so go ahead and change part C to say f of x equals -1. Here, -3 is an input value. So if I have an input value, I need to look in my x row. So I'm going to go along my x row. Here is -3 for x. Let me get my pink marker. And then I'm going to find the corresponding y value, or f of x value, that matches with that input of -3. So here my answer would be 2. I'm going to do the same thing in part D. I'm going to go along in my input row until I see 20. And I'm going to grab the corresponding y value, or f of x, or output value that matches. So my answer here would be 0. In this case, I know what my function is equal to. I know my output. So I have to find where my output is -1, which is right here on the table. So my answer for C would be 0 because that is an input value. I could also say x equals 0 if that's helpful. And then for part D, I have f of x equals 9, which means I'm going along the output portion of my table to find 9. So here, my x value would be what matches with that. So x would be equal to 2. And I'm going to add one more in here, letter E. What would happen if I told you that f of x was equal to 4? This is an output again. So I need to go along my output. But there are 2 different spots where my output value is 4. So I need both of these answers for part E. So I would say that x was equal to 9 and that x is equal to 7. So both of those will be answers.